Hi, welcome to the session on enhancing biodiversity monitoring and reporting at the subnational level. If you need translation service, there's a QR code right here, but it's also at several places in the room and also on the counter right there entering. So there is no formal introduction to this session. I will start right away with my presentation, which is the first, and then introduce all of the other speakers from various organizations around the world. But we have a lot of representation from Canada, actually. I don't know, it attracted Canadians. Oops. What is this? Well, while we're waiting for my presentation to be up, I'll give a bit of justification why doing something subnational presentation. I think we hear a lot about the GBF, the global biodiversity framework, and it's a very important thing. But a lot of things are happening at the park, the city, the provincial or state level, and a lot of work happens there that needs to be highlighted. And we were thinking this could be a good venue to start thinking about this. To not start thinking, but to promote what is being done at the subnational level. All right, so my presentation now is called Bridging Scales and Borders, Biodiversity Variables Calculation with BON in a Box. We are together in this journey to understand, monitor, and protect biodiversity, yet we are scattered. This conference is a very good illustration of the will to get together and unscatter. 4 different networks, people meeting, people discovering what the other organizations are doing, and trying for these bubbles to happen a bit less. Like, I have this awesome thing that I have in my Jupyter notebook, but I don't know about it. Hey, where's the code again? I can't find it. Or all these sort of things. Communication is key. So the theme of the presentation will be about sharing, especially sharing the workload of calculating indicators and essential biodiversity variables, because we know each network has their strengths. ABMI, that we'll present today, are really good at backfilling layers for before human imprint was there. Biodiversity Quebec is doing SDMs, and correcting bias. All these organizations have their favorite indicator, their favorite variable in which they are experts. But we all face the same challenges. So why not share this knowledge in an even more easy way and get the mutual benefits that emerge from this collaboration? So I will present the BON in a Box pipeline engine, which is meant exactly for that. And I'll highlight a few common data transformation problems and organizational benefits that emerge from using the BON in a Box platform in your organization. BON in a Box is a software to integrate data and models into a nice UI, and it allows to calculate biodiversity variables and indicators, like I just mentioned, but it's based on community contributed analysis pipelines. It's very important. It comes from the scientific community. It's not directed by a decision necessarily from the top. And it's open source in a curated repository. So there is a means of checking what comes from the community and assessing if it's valid. And when calculating the indicators, you can feed on local or global data sources or a combination of both. For example, here in this data transformation chain, this is more GBIF, OBIS that is there. BON in a Box is in this part of the pyramid, EBVs and indicators. If we take an example with Colombia, we are in Colombia, right? Plus, Humboldt has been working with us from the inception of this Humboldt Institute, from the inception of this new phase of Bon in a Box. So they are acquiring raw data that goes into GBIF or OBIS or in their own data sets. They know how to calculate interesting variables on this data. And this knowledge lives inside the Humboldt Institute. If they take the effort to generalize this, to make sure it works elsewhere, and put it in the Bon in a Box platform, then another party elsewhere than Colombia, or another institution, maybe a more local institution, can use the same things. So in that case, another party, or bridging borders, going back to the title of my presentation, and if you can run the same thing in a national park that you were running nationally, globally, then we're bridging scales. It's possible to do local adaptations if needed. So what was done here might need a few adaptations in code or in parameters to work elsewhere. It's a huge accelerator for reporting and not just for the GBM. When we calculate these indicators inside an organization, it usually stops there. You take the paper, you read the paper, you implement it. Maybe there are a few errors and you don't notice. You use these results. Some organizations go further. For example, Ben Halpern with the Ocean Health Index really went all the way here. So the first assessment they did took them a full year. The later assessments are much quicker to do because they have automated the process. We're proposing to go all the way here, peer-reviewed pipeline, a stable core that has been validated by external person to the people who are actually developing the code. In addition to having a peer-reviewed methodology, a peer-reviewed pipeline removes a lot of the possible errors. For example, for our protected connected index pipeline, we have the Santiago Sora, who is the author of the methodology, who reviewed the pipeline. We had the two authors of the Makorhini package, which we are using for the calculation, and also Cory Ruha, an independent user from New Zealand, who have reviewed the pipeline. And it was also tested massively by UNEP WCMC through the UN Biodiversity Lab, where it's now integrated. So this is a screenshot from UNBL with the little powered by Bon in a Box logo. So this is our first pipeline that went through peer review. We have other pipelines and other coming up. It all comes from the community, as we mentioned, and we look forward to having more peer-reviewed pipelines. In order to run a custom analysis, we go back here. This has been pre-calculated, right? So you don't have possibility to change this. A user actually can choose the parameters. Let's run the same thing, but for a smaller region, for another species, using my own data set, the possibilities that can, because the workflow is transformed into a form for the user to fill. There is full transparency when we run. You have access to the code. You have access to the references, the logs. You can see everything that happened. So you can trace also the source of error. It's not a black box at all. But your manager doesn't want to see the logs. So you can present the result in this nicer viewer, which contains only the outputs. The idea behind all this is that you don't need to develop your own shiny dashboard, your own web application. If you just want to integrate a pipeline, some visualization is already provided with the tool. And finally, this is what the contributor sees, but I won't go into details. Just know that each of these are steps backed by scripts described by metadata. And if you want to know more, if you want to contribute, come and see us at the booth, and we can discuss what you are doing, if we already have things in the platform that could help, and give you a full walkthrough. At the boot, I said at the boot, but the GEO BON boot, yeah. One thing that was expressed in the first plenary session was the concept of the leaking data, right? Data that indigenous people own and they don't necessarily want to let go, or maybe they want to put in GBIF or something like that. But let's say you have data that you want to keep on your servers, you can own the process with Bon in a box. So you have your instance running on your server with your data, but you can also pull in global data, geospatial layers, whatever, and you can, if necessary, derive the peer review pipelines into your custom pipelines if you need it. You can also completely delegate, which means if you don't have any sensitive data, you send all this to a public instance. This is currently possible to run only with global data. This uploading feature is not there. This is why I wrote future development. But everything on the right-hand side already exists. If you want to try it out, come and see us at the booth. We'll give you also a card if you want to contact us later on. We have a few pipelines, but I would say this slide was made a few weeks ago, and we have already like 3 or 4 more indicator pipelines from CSIRO in Australia. We also have a sampling priority pipeline that was added. These are all considered in development because they were not peer-reviewed, except, of course, the protected connected index that I mentioned. Others will follow up. Common data transformation problems. The indicators are not always accurate because we make so many mistakes or imprecisions. The ones we look towards in Bon in a Box are those. So understanding the methodology correctly, implementing it correctly, while we have this peer review process that helps to remove these errors, misunderstandings that could happen. For the parameterization and result interpretation, the biologist that is running the pipeline only needs to understand the concept of the pipeline and also know how to analyze, but not to code. But we also provide guidelines to help with the process, in addition to the paper references that you can read, of course. The organizational benefits, the most evident is you're able to use what others did. The second one is make your organization shine. Bring your knowledge to others. And also I'm citing Lena, who's in the room. Because at Humboldt, they were there during the inception and they worked with us while the tool was being built. And they found out that it improved their organization and standardization, collaborative work. It helped them assemble bits and pieces that were scattered into like a unified pipeline. So it has some organizational benefits just inside the same organization, even if you're not sharing. Okay, I have 1 minute left. So if you have questions, come to the booth. There are also challenges because there is a learning curve if you want to contribute, but now we have Jory who's there to help you doing this. That's her role. And also you need the installation is somewhat hard. We can help you with that too. And generalizing your workflow is not always easy, but it will make it better because we'll find errors and you'll be able to correct them and your workflow will be even better. So I'll skip that bar, unfortunately, and just say, come and try it. Think about what is your expertise, if it can be shared, and maybe your next analysis will be powered by Bon in a Box. And thanks to all the collaborators in this room or elsewhere. We don't have time for questions, right? Too many anecdotes. So,
that's my phone.
That's your phone. Sorry, I thought it was mine.
Yeah, I need a timer.
Our next speaker is Brandon Allen from Alberta Biodiversity Monitoring Institute.
Awesome. Thank you, Jean-Michel. Yes. Yeah, thank you. So yeah, I'm going to be very much continuing on this topic of using BON in the box and trying to understand how we can apply regionally developed species distribution models to international biodiversity indicators. So off the get-go, though, I'm just going to acknowledge the species model I'm talking about today were developed by a large group of modelers, both at the Alberta Biodiversity Monitoring Institute and the Boreal Avian Modeling Institute. So I think we all agree that there is a challenge in monitoring biodiversity. Biodiversity is big, it's the variety of life, but we can't represent it by a single species or habitat. So in recent years, there's been a large push by the international community to make sure that we have sustainable frameworks and targets that can help support halting and reversing biodiversity loss. So in theory, this is relatively simple. So, all you got to do is create a national biodiversity monitoring program, as easy as that is. Once you do that, then you do data analysis and synthesis. You do your planning and prioritization exercises, reporting on progress, and the cycle loops forward. And as Jean-Michel said, one of the challenges is that even though a lot of countries have national biodiversity programs, there's also a ton of regional and subnational programs that are happening. So trying to understand how all of these pieces fit together is really important. So our organization, the Alberta Biodiversity Monitoring Institute, we're a value-neutral nonprofit who began operations in Alberta, Canada in 2007. And again, we are operating in this sub-regional space. And so we've been trying to track changes in wildlife and habitats across Alberta. We provide scientifically credible information about our living resources. So we are very privileged in Alberta. So we have a monitoring site of 1,656 sites, evenly distributed throughout the province. We do monitor birds like everybody else, but we do also monitor mammals, mosses, lichens, vascular plants, soil mites, aquatic invertebrates, and amphibians. So we do have a wide breadth of taxonomic groups that aren't really covered by many national programs or subnational programs. And one of the cool things is that at that sub-regional level, we've been doing lots of reporting. And at the international level, national level, we've seen the development of essential biodiversity variables. And it's wonderful to see that there is broad agreement on indicator intent. So we're all concerned about ecosystem distributions and disturbance. We're all concerned about species distribution and abundance, community abundance, habitat structure. And so there is significant alignment in what is happening at that subnational scale with what the international community is interested in. But again, the underlying methodologies might change indicator interpretation or results. So this is where I think BON in the box plays a valuable role. So groups like ABMI can work with our academic partners, other ENGOs, Indigenous communities and industry partners to collect regional data and develop pipelines. We can then use BON in the box to say, what happens to the indicator results? So if we use national data versus using regional data, do we come to the same conclusions? What is the source of error that's happening there? And how can we bring regional data up to the level for international reporting? So I'm going to talk about two examples today, and I'm so happy you went first, Jean-Michel, because we're going to talk about the Biodiversity Intactness Index and the Species Habitat Index. So the Biodiversity Intactness Index is meant to measure the accumulation of change in species abundances across a broad set of taxonomic groups. We're measuring this through some sort of reference landscape. So in Alberta, our reference landscape is a pre-disturbance landscape. And then we also have the Species Habitat Index. So this is trying to measure the change in area and connectivity of suitable habitat compared to a baseline year. And so let's focus on the Biodiversity Intactness Index. So through the BON in the box platform, you can query it and you can get the information that you need for a subnational jurisdiction for whatever year of interest. And so this layer is based on the UK Natural History Museum's Global Biodiversity Intactness Index. So this is a 10 kilometer squared resolution data product. It is a global scale land cover inventories. It is global scale species distribution models. And so you can see on the right here, you can see where in Alberta has probably been impacted. For reference, for those of you not from Canada, that is our agriculture area of the province. So it's, most of it was grasslands previously, and now it is crops. We compare this to the ABMI product. So again, we have developed about 1,000 species distribution models across 7 taxonomic groups. The land cover inventories that we're using are a lot of photo-interpreted land cover inventories. And we aggregate this information or make predictions at a 1 square kilometer scale. But you can see we have very similar spatial patterns. So we had groups in the UK using national indicators or national data, and groups locally doing fundamentally different things. We've come to the same conclusion of where there is biodiversity maintained in the province. So I think this is really cool. And bounding box help facilitate these types of comparisons. And so for future conversations, we can start asking, where do these differences start to matter? So if we're trying to compare countries to countries, the national or the international products are doing a really good job. If we're doing within Alberta sub-regional planning exercises, using a more regionally developed product might be appropriate. But we can get even more into the weeds on these types of comparisons. So again, as Jean-Michel said, there's a species habitat index available for the bounding box pipeline. So this figure here on the right is actually taken from the Map of Life. So this was their estimates of the species habitat index in Canada as of 2021. So the x-axis is representing the score in this index. The y-axis is the number of species. You can see it's divided by an area score and a connectivity score. So again, the big question is, what happens if we use regional data? What does it look like in Alberta? What happens if we use national, international data? And do we have the same story? And so I like going into flow diagrams. I think they're really interesting. So this is the baseline framework for the bounding box platform. So you have the IUCN range maps, and you have Copernicus to get a DEM. So we're using that to filter out a potential range of habitat and non-habitat for species of interest. Use global forest watch data to determine where is this forest lost or regeneration. And for then every year of interest, you can then go to the next step for section 2 of estimating how much habitat there is, what is the connectivity of this habitat, and then aggregate that into a final score. So this is where we can start to change things. So we can say, instead of the IUCN range maps, which Alice talked about the other day, saying we know they're not perfect, what if we replace that with a provincial SDM to get a better estimate of a range for a species? But then we walk it through the same process. So we say, you know what, let's use the DEM. We'll just refine some of those predictions in case there's some stray predictions there. Use the global forest watch data to estimate where change is happening on the landscape, and estimate a score of habitat and connectivity. But we can also take this a step further. So again, we can just say, what if we fully replace that first part of the pipeline and bounding box? So instead of relying on range maps, we just rely on SDMs. So the way that we've built our SDMs, they're sensitive to land cover type, but also forest structure. So as forest ages or they burn, the habitat suitability for a species is going to change. And it's also sensitive to a wide variety of human disturbances. So things like energy development, forestry, and agriculture. And we can just use this to define habitat and non-habitat. And again, we get a habitat score and a connectivity score through the bounding box pipeline. And we start to see some really interesting differences. So this is the first example. So we're just going to use baseline bounding box versus if we replace those IUCN range maps with regional information. And this example here is just for boreal chorus frog between 2010 and 2020. So again, there's lots of areas that are really similar. And you can see there's some differences in the northern part of the range. And just expanding on what Alice talked about the other day, the IUCN range maps just might be overestimating the total area that that species occupies. And so in this case, we'd be overestimating the amount of impact that is actually happening to habitat relative to boreal chorus frog. However, like the same is true for the SDM approach. We know SDMs aren't perfect. So when you binarize them, we might be underestimating the actual range of the species. And we might be missing important lower quality habitat that could become very valuable as the climate changes. And let's look at the more complex example. So again, this is the bounding box version on the left in green. We have the species habitat score, species habitat index on the x-axis, number of species on the y. And we're comparing it to just fundamentally replacing that first step and saying, let's just use regionally developed SDMs. And you can see biodiversity responses are complex. And I think the key things that we're starting to see is that species that have negative associations to forest loss have similar magnitudes of changes and similar directional patterns. So American red cert is a great example. So, the baseline bounding box tool saying 89% versus regional SDM saying 92%. That probably doesn't matter in the grand scheme of things with all the uncertainty that we're already trying to account for at these scales. Where we start to see differences are species that do respond positively to human disturbance. So coyote is a great example here. So we're predicting for regional data that they're relatively stable over time compared to the loss through the baseline bounding box platform. And coyotes are highly opportunistic. They exist in our pastures and our crop fields. When I go for walks at Edmonton, I often see them hanging out in the river valley. So they aren't terribly just concerned with forest loss. They're going to occupy those habitats. And so I think this is just starting to highlight some of the challenges that many other people have talked about, that alignment across jurisdictions is hard. I have seen countless frameworks just at this presentation or at this conference so far on how to develop SDMs. And again, there's always going to be nuance in the data that's available to you. Are you using presence-only data? Do you have presence-absence? Is it density models? Some of the other challenges that we always face are that the scale that we're working at might change the land cover inventories that we're using. So if we're interested in national, international scale, we might be using coarser thematic classifications for our land cover inventories. And that might miss key nuances that regional products might be able to grab. So if you are a species that loves only shrubby bogs, you might need a regional land cover product that accurately maps shrubby bogs that just isn't available at a global scale. And the other thing too is needing fine scale footprint information depending on where you are in the world. So in Alberta, we have a lot of energy development. So we have seismic lines that are about 1 meter wide, and we have hundreds of thousands of kilometers of them. And those just aren't picked up by even Landsat or Sentinel-based products. And so you need a lot of local LiDAR data to fully map these features and understand the impacts of them. However, I do think there are more opportunities than there are challenges. So I think active collaboration is going to be key. So contributing data to public repositories to facilitate these larger national and international modeling efforts is really key. Using tools like BON in the box to be able to share reproducible methods across jurisdictions helps us understand how indicators are going to respond as we use different data sources to make sure they're accurate and we're coming to the same conclusions. And I think these collaborations with these international efforts help ensure that international indicators reflect local biodiversity concerns. So in summary, I think indicator alignment is a worthwhile challenge. There's always going to be difficulties aligning methodologies across jurisdictions, but I think as long as we maintain indicator intent, we're sharing data, fostering these multi-jurisdictional collaborations, we'll continually improve the reliability and credibility of national biodiversity indicators. So with that, I'm happy to answer any questions. Right on time then. Do we gotta I'll lean over and share a microphone.
It's
very
like,
intimate.
yeah. I like it. Maybe I'm not capturing all the information, but I know that using Galaxy Ecology, one thing we are seeing is that when we share workflow, it's quite easy with a lot of brackets to give it to users so they can just use the same workflow, but on their own data, who can be a subsample of the national data or international data, for example, to have their local or local indicators. For example, for breeding bird survey in France, we do that, but it was quite easy with a lot of brackets technically, because this is just subsampling the data, the original data for the region where we want to produce the indicators. But there, I think you compare, in fact, you compare the use of indicators at the subnational levels, but using different kind of data. That's it, if I am not saying a mistake. So, so my question is, did you try to just, with the other bracket, reproduce the use of the workflow on the same kind of data, but subsample for the region you are working? I don't know.
Yes. Yeah. Yeah, so all the comparisons, the way that we went about it is we use BON in the box to subsample all the international available data to Alberta and calculate these indices. And then again, like at an international scale, I hope there's somebody that has soil mite data. I doubt that they do. So we were able to use more species information that's relevant and locally collected to then say, what does this look like in an Alberta context if we start substituting data sources?
I love your question. I use species habitat index in my PhD thesis, but I use the score of the index download of the page of the one.
Like the map of life download?
Yeah. You calculate the score for a specific place.
Yes.
Yeah. In this case, the place is country or another part of the country.
So this was for Alberta, Canada. So yeah, we used through the BON in the box platform, we subset Alberta and then use all the international products to give us an estimate.
Got it. But you compare your index score versus the score in the database of the index and more?
Oh, sorry. I used that as just an example, just to illustrate that you can talk about that at an international level. So the map of life stuff was just saying Canada, this is what it looks like, trying to describe what the index is. Yeah, that was just an illustrative example to show that.
Okay.
So ours was local to Alberta species habitat index, and use the Box platform to then use international data.
Okay, I have many questions, but after.
Okay, yeah, we can chat after. We're good. Okay, we got to move on. Okay. I will take your phone.
Thank you. Is Vincent Beauregard, presentation is linking biodiversity and well-being, a case study, subnational bond reporting for Quebec.
Great, thank you. Happy to be here. So I will be especially talking about how we developed and implemented indicators to fit into that dialogue between biodiversity and well-being for the province of Quebec. So to start, perhaps a few words about the province of Quebec and its context. To start, it's a big piece of land. In terms of ecology in the south, where most of the population is around the St. Lawrence River, it's temperate and mixed forests. While in the center, we have boreal forest, and up north, where there are indigenous communities, it's subalpine Arctic region. So it's a very hard geography to sample in terms of ecology. And in terms of land mass, it's about 1.5 times the area of Colombia, while the population is less than in the metropolitan of Bogota. So it's hard to sample, and we especially can see it with the biodiversity and the data where the mass of the biodiversity is concentrated in the south. Also, on a cultural and political level, you can hear it from my accent, we speak French, and it traces to the political system. So we have governments at the provincial and a national level where they take a lot of actions and decisions based on biodiversity or for biodiversity. One great example is the species at risk. Both levels of governments has their own law governing how do we protect species and track species population, and each level has their own red list that often conflicts. So this is pretty hard challenge to work through. And also in terms of international agreements, both have committed to the Kunming-Montreal biodiversity framework. So they need to track their progress at each level to achieve the targets. Finally, an important level of government is local, where there are a lot of decisions made for land management or conservations. So we at Biodiversity Quebec take that into account. So we operate as a Biodiversity Observation Network. So what we are a scientific partnership between the government of Quebec, University of Sherbrooke, and the network of biodiversity researchers in Quebec that is called QCBS. And basically what we do is we develop infrastructure and provide information on the state of biodiversity. An example of that is that the government of Quebec operates a survey network of 502 sites revisited regularly since 2016 across many taxonomic groups. From this data and other big data sets and local data sets, we conduct analysis, so indicators, EBVs, distribution models, and climatic projection. And finally, we develop tools to improve decision-making. Those can be either web-based interactive tools or data products like the key biodiversity area for Quebec that is coordinated for the province at University of Sherbrooke and Biodiversity Quebec teams. So with that expertise, we were approached by a think tank in Quebec, the G15, which basically is a coalition of many different sectors of the society. This includes labor, business, unions, environment, community, and they want to push forward the idea of economic transition. And to do that, they promote a tool, which is the Indicators of Well-being of Quebec, which try to track all the dimensions of the donut economics, which basically tracks the well-being as defined by the minimum resources required to support the society, which is the employment, the housing, the health, but we need to do that by respecting the terrestrial limits, which is land use, water, energy, and biodiversity. And they were lacking good indicators to track biodiversity in that framework, so they came to us with our expertise about indicators development. So what I will present today is this indicator design and process, how we used BON in the box to standardize the pipelines to compute those indicators. And finally, we'll discuss a few use cases and how we develop those indicators. First, the development process. First, we selected, there are many available indicators for biodiversity, I'm sure you all were well aware of. So we defined a few selection criteria. So first, a few of them, we wanted to make sure that data is available and it's feasible within the time we had for the project. There was a big need for us to be able to communicate quickly and clearly the result of those indicators to the civil society outside of the academic ecology researchers. Another one is that we need those indicators to be credible and robust by being supported by established methodology. So we designed those indicators. We implemented a consultation review process with experts for taxonomy groups and biodiversity question at governments of Quebec and our partners at G15+ to make sure that the indicators that we choose will be able to be communicated. And then we compute them and standardize those indicators by using our pipelines and then by standardizing in BON in a box. So BON in a box, Jean-Michel presented it well. So for us, Biodiversity Quebec, it's really relevant because we can reuse pipelines, we can standardize those pipelines, we can integrate both local and global data sources. And we basically always work in R to do our analysis. So it's really easy to integrate some modular R scripts to do data access analysis and visualization steps for those pipelines. So the selection process of the indicators. At first, we selected 11 indicators that we had implemented and observed. And those are across 7 dimensions of biodiversity that can or may not be related to EBVs, but some of them are very well known, such as species at risk population, invasive alien species, and land protection. But we wanted to represent also other aspects such as contribution to the economy or biodiversity knowledge. And from this whole process, we ended with 4 indicators for those 4 dimensions. And so I will present to you a few of those use cases. So the first dimension we wanted to represent is the species at risk. We selected, we selected 2 indicators. One is Living Planet Index, which tracks the population trends. and for especially only species at risk. And the other one is the change in protection level that is inspired by the IUCN Red List Index. In the end, this one represents well the ecology of the population, which is their trends, while this one proved to be very hard to communicate because it integrates a lot of information, which is the population species decline, but also the monitoring efforts and the efforts of policy conservation. So the message was ambiguous and we preferred that one. So this is the kind of decision we had to make. We developed also an indicator of conservation, which is basically the percentage of area conserved. We developed it as a pipeline in Bon and Box. So this is an application from Putumayo province in Colombia. And it's really well because it allows us to compute and observe the results. But we compare the results with percentage of protected territory using local and global data sets. So global data sets is WDPA, and we use the local data sets, which doesn't result in the same result, simply because the latest local data set is more up to date. And also by using regional topographic polygons, we were able to answer important decision-making for tracking for Quebec, such as like the representativity of those protected areas. So for example, what is protected above the 49th parallel or under, and what is conserved, for example, as a marine ecosystem. So basically, local data sources are important for timely local decision-making and reporting, whereas global data sources and indicators are really relevant for international comparisons, and both are important. So I'll track all those use cases to the take-home points. But this is really a challenge between striking a balance between capturing the ecological processes, but the context of the decision-making. And this is why collaborating with the government of Quebec and deciding on those indicators was so important. Also, the local data and pipelines are essential to reflect the subnational context and decision-making. So the North versus the Quebec, we can't capture that only through the global data set, but it requires a lot of work to adapt data sources to our context. And finally, it's really important to have a Bon in a Box for us as a tool for standardization and collaboration, but also those indicators we developed, a few of them have been standardized. It's a work in progress, and it's an effort that needs to be budgeted and planned by team. So with that, I don't know if we have time for questions, but feel free to reach out.
Next presentation will be online. Guillaume Body. Sorry? It's a video, yes. Harmonization of protocols across scales, lessons learned, and advice from Biodiversity Plus. Any question for Vincent? Offline?
Oui, j'avais un peu la même question que tout à l'heure, mais les données qui étaient utilisées en entrée, en local, c'était pas un subset des données de l'indicateur. Je trouve ça super compliqué parce que déjà, rien qu'en prenant un subset, on est sûr de pouvoir faire tourner le pipeline vers des choses comparables. En prenant d'autres données, ça fait vraiment plus carrément les protocoles de production de données, c'est un peu ce que tu disais, mais je pense il y a déjà l'aspect technique quoi, que le box fait, ou en élection peut faire aussi, de pouvoir faire du subsetting. Et après, la transposition un peu au niveau de type de données, c'est seulement en soi.
C'est un des grands challenges. Puis, au final, nous, ça nécessite, I'll answer in English, but the question is about the challenge of subsetting and having local data sets and actually filtered data sets. And for us, we had to implement to use other data sets such as polygons and limits to reflect our context. And this is not global. So we were having the two pipelines side by side. And first developing our pipelines and then adapting it for deployment flux context.
Something that could also simplify the step is that you could use one in a box with global data only, and then with local data only in the same pipeline, or with a combination of both data, or do something like Brandis did, and you just cut off part of the pipeline, use the end of the pipeline, and supply his range map instead. So the possibilities really depend on the context of the organization that is making the analysis.
But we have to be honest and say that this adds an overhead to the process. So, and it's important to put that effort, but it really needs to be planned. And sometimes we just don't have the time to do it. So.
But sometimes just subsetting the global layers just doesn't work. So, and the people that at the provincial or state or national level are say, well, that global layer, I know it's wrong. So I can't own a subset if I just want to use my own.
So we'll skip the video. Anne-Sophie Archambault. Oh, I don't have it in this. Okay, so Anne-Sophie. Ivan, speak talk. Go. I'll go. I had copied the schedule before coming, and apparently the schedule changed. Sorry. Ivan Lebrun from the Natural History Museum of France.
So I think I have a short talk, like 5 minutes. 7 minutes. Maybe I can take 7. I can also sing a song. It's like 5 minutes. Yeah, thank you. So to present the organization, we are in France around this French BON, and notably recent works we have done. The idea is to show a little bit the context, with Back to the Future, and present a particular workshop we organized last year, the French BON days, and look at the perspective towards the integration of French biodiversity observation network. So really briefly, the landscape is complex, a little bit like this slide, and we need to have a fair data framework for studying and monitoring biodiversity. And to do so, you can directly go to the funny slide, speaking about the fact that in France we are organizing as a French BON since years, thanks to the Ecoscope initiative in 2012. After that, the Pôle National des Données Biodiversité, so the biodiversity data, where I am the scientific and technical coordinator, takes the lead of the work of Ecoscope and notably the lead of the French BON. And since 2018, we are developing this EBV operation pilot, notably creating EBV workflow to Galaxy and Galaxy technology. And since recently, 21, research to federate research organization and public policy around this French bond. And last year, we worked in more integrated nature to the research infrastructure of the university. With Data which oriented towards the first system, and we organized this French Bond Days at Sète. So Sète is a beautiful town in the south of France, almost as beautiful like Concarneau, where I live, in Brittany. And it was really cool to have these beautiful days. But this slide is not so funny than the picture, sorry for that. The idea was to be there and discuss between researchers, research communities, services to research communities, and public policy colleagues, and notably to look at the best practices we can share in terms of data management, notably, but also for the communication, the organization, and the move forward new French bond organized really with research and public policy. We had some trainings, workshop, plenary session. We were 37 people, 23 remotely. It was really cool, nice, good wine. And we said a lot of things, but notably the fact to work on manifesto and being an integrated framework, skill definition, because since the first creation of the French bond, we see that we evaluate a lot, but the original manifesto is not up to date, so we have to rethink to that. And to identify and clarify existing data indicators, bridges between research and behaviors. We'll not go into much detail. The idea is notably to move forward the direction where we can take example of what is doing in Canada, notably with Cameroon, and also in Australia to the chair, the Australian System Observatory, and inspiring also a framework from the regional level. So there is the European Biodiversity Observation Coordination Center, who is created in Europe, and we want to also benefit from the creation of the National Biodiversity Monitoring Coordination Center, so in France and other European countries, to take the opportunity to take part of this regional network from France. And for sure, we will also inspire from frameworks at the international level, like the GEO observing system for biodiversity and national goals and global networking. And some references. And thank you. If you have questions, I think we don't have time, but don't hesitate to look at me or at Sophie at the coffee. Thank you very much. Very quiet.
Try to speak so little, so you can ask your question.
Or do we move on to the
No, because my colleague will go after that, so
okay.
So
one question, sorry, now.
If you have questions,
I see you have a Galaxy t-shirt, which I think I understand has a similar goal than Biodiversity. What do you see from your perspective in using Galaxy?
I think it's clearly similar to I will differentiate Box pipelines, Box, because for me, Box is really larger and propose a lot of good practices and methods that people can use to create bonds on regional national level, aside from IT things. For Box pipelines, and we have in Galaxy Ecology for the EBV of pilots, the same kind of things with this orientation towards EBV, with the workflows, sharing it, and something else. The big difference, in my opinion, is that we were benefiting from Galaxy with a web platform since 20 years. There is a big community, there is a big platform existing at continental levels, West, Australia, Europe. So we have big infrastructure, big resources, and colleagues who are dealing with that. So we are just trying to use existing things to see if it can fit to the needs of the ecological world with Galaxy Ecology. So since 7 years now, and it's good to know that apparently we are in good direction. With box pipeline, the idea is completely different, in my opinion, because directly you are taking the needs of the communities and the needs around EBV to create something around that. So I think we have similar objects, similar things. We don't have the same kind of manner to deal with resources or the production level, even because we can already use Galaxy and use tools and planning and like that. But I think it's really interesting to see the things where you try or you are developing something which is coming really to answer the needs of the communities, where we are more to try to use existing big platform and things like that to see if it can benefit to use for ecological. I think both are really interesting and important to use. Just to compare one big things we have, we don't have an issue with Galaxy or the funding, nothing like that, because there's a lot of funding on Galaxy, there's a lot of resources and things like that. So we don't take risk to try to use it, push code on that. With Biodiversity, it's completely different. You are trying to push something with new Biodiversity pipeline, and you need to have funding, collaboration, and creating it, but step by step. And I really think that we are in connection and we are changing really often. I may be more open in the future, but I deeply think that we can collaborate, try to make it like that. So when we develop a model of pipeline or Galaxy ecology, it can be federated and used by the author, depending on what the user wants to use or prefer to use. It should work now.
Diversity monitoring at the subnational level, we're going to tackle a critical question. How do we harmonize local monitoring results so they integrate seamlessly across the entire continent? Your subnational biodiversity data is incredibly valuable and scientifically rich and essential for completing the continental and global picture. The challenge is just hard to integrate those subnational results when we look at the sheer scale of diversity. So here, for example, the two pictures are from France itself. So even from subnational to national level, we have this complexity, and even more so when we try to go transnational. So the problem is clear. We're managing biodiversity data across an immense and diverse continent. And the challenge isn't just ecological, it's also institutional and cultural. And now for the last 3 years, Biodiversity Plus, the European Biodiversity Partnership, has been working specifically on this question. And we've learned some fundamental lessons, and we'd like to share some of our actionable advice with you. And now, so how do you solve something like this? Biodiversity Plus's approach was to put the experts together in a room with sticky notes and a bunch of sticky notes. So we used a consultative and collaborative approach where we brought together the experts to think together. And by experts, we mean the decision makers from environment agencies that would ensure the solutions are governance-proof and realistic, and also the technical experts, of course, so monitoring coordinators, thematic specialists, and biostatisticians to ensure that the methods are statistically sound also. And we conducted workshops, discussions, and we built upon extensive literature reviews also, and we did a few mappings, and we wrote some reports with the main results and advice. And also we've been collaborating with other major European projects. And what did all of this collaboration teach us? We learned two main lessons. So lesson one, harmonization is a strategic alignment, not a rigid standardization. So it's not about forcing everyone to use the same field tools, because that would just be messy and honestly impossible. Instead, we align the critical elements that guarantee interoperability. So we would agree on would be the common minimum requirements for the monitoring protocols. What do we mean by these common minimum requirements? They're essentially the baseline ingredients that every biodiversity monitoring protocol needs to share in order to make the data comparable, interoperable, and policy relevant, even if they're applied in different contexts. These minimum requirements will help ensure that when we combine or compare the data from different regions, we're not just mixing different things, apples and oranges. And we can think of them as a set of guiding questions that every monitoring protocol should be able to answer clearly and consistently, and that you should all think about these questions. So what would these be? These questions would be, for example, what is the objective? What question or policy goal are we monitoring for? What is being monitored? So which species, habitat, processes, at what scale, spatially and temporally, what's the minimum coverage and frequency? How is the sampling done? So what's the sampling design and the sampling units, their size, their strategy? How much sampling is enough? Is there enough effort to detect real trends and to be statistically relevant? And how were their results reported? Or the outputs expressed in comparable formats and indicators that we all agree on? We would focus on identifying which elements must be aligned across protocols because they affect data integration and the statistical robustness, and which of these elements of the protocols can remain more flexible to allow more local adaptation. So each element can be classified as strict, or that must be strictly harmonized, or as flexible, that can vary as long as it's transparent and well documented throughout the whole process, of course. So for example, the sampling unit and agreeing on the smallest unit of observation would have to be strict as they determine the whole comparability later on with the results. Meanwhile, the sampling strategy, let's say if it's a random sampling strategy or stratified, that can be flexible. There's ways later on to merge the data from different sampling strategies. And also there's some focus areas of major importance and that we have to be aware of. So first of all, of course, the objectives, they are the foundation. They influence everything that you monitor. So having very clear and well-defined objectives are just essential. Then there's the power of sampling design. We placed a particular emphasis on here because it's relatively independent of the taxonomic groups that you are monitoring. And the sampling design governs comparability. Differences in scale or frequency can break the whole chain of interpretation. But it also allows for flexibility by setting some minimum thresholds. For example, setting the terminal sampling unit. You can maintain a harmonized backbone with the core network while retaining some local capacity to upscale. If you have the possibility to do more than the minimum, go for it. And so this is what we propose, to have a core minimum in order to scale up. And also the EBVs, Essential Biodiversity Variables, they are key. They would be a key common language as they are a middle step between the raw data and the indicators. They provide a way to harmonize specific monitoring targets that do not require to standardize the protocols, as you can apply locally the protocol of your choice and produce the defined EBVs that will translate into a transnational scale. And also something that we recommend is to share both EBVs and the raw data set because they would answer to different needs, and then you have just more flexibility on what scale do you want the results of the monitoring. So now moving on to the second lesson. The harmonization requires a dedicated governance engine. The common minimum requirements for monitoring protocols are good, but they are very generic. And they must be fine-tuned by experts for your specific monitoring target. And we realize that this process is social and political as much as it is technical. And you need a layer of coordination to build upon the existing expertise. So who can do this work? As we said, experts on specific taxa, habitat, or regions on the target of your monitoring. And if we want to harmonize at a larger scale, we need these transnational networks of experts. And another reason to talk about this is simply that these transnational biodiversity monitoring communities, they already exist. They take different forms and functioning, of course, but we have mapped 60 thematic monitoring communities from all realms and whether it's taxa or habitat. And this would be, for example, a bird monitoring community, butterflies, Posidonia, soil biodiversity, just to cite some very well-known ones. And now one of our solutions on how to integrate them into the governance landscape would be to integrate them as thematic hubs. And this is not just us within Biodiversity Plus that have acknowledged the value of thematic hubs in the biodiversity monitoring governance landscape. You might be aware of the Europa BON proposal for a European Biodiversity Observation Coordination Center. I will not get into the details now here in this presentation, but just to say that it involves thematic hubs, so as involving the communities and expert groups monitoring EBVs as essential players into the coordination and the governance landscape for biodiversity monitoring. So for us in Biodiversity Plus, these thematic hubs or transnational network of experts focused on specific themes. So let's say butterflies, marine turtles, forest biodiversity, you have here the tiny icons. And they would enable scaling from local, national to continental results, aggregating with meaningful comparability the results. And these hubs, they would be both technical and social. So they would group the technical expertise from a scientific point of view and very technical. And also they would provide a platform for exchange of best practices and see what is being done also by the experts on your same topic, but elsewhere. And all of this would allow to have a more harmonized idea linking the national efforts to the European level results. So to wrap up, what we've really learned through this work is that harmonization isn't about identical protocols everywhere. It's about building a shared backbone strong enough to hold our diversity together. So the common minimum requirements, they give us that backbone, and they're essential standards that keep our data comparable and meaningful. And the EBVs are also very helpful to give us a common language also, and a common objective in a way. And to make that backbone function, to actually move, learn, and adapt, we need the thematic hubs that would translate the principles into practice, support capacity, ensure quality, and help local monitoring feed into the European and global assessments. And together, they transform harmonization from just a theoretical goal into something operational, scalable, and more inclusive, with a big human and social part of it as well. That's really important. And that's ultimately what this work is about, but not one size fits all standardization, but that coherence through collaboration so that every data set from every country contributes to a clearer picture of Europe's biodiversity and its changes through time. And so within Biodiversity Plus, we propose this as a starting point, and this work is ongoing. So let's keep building this together. Thank you very much.
I know it's getting very hot in here. Hang on. The two next presentations, just so you know what's upcoming, we'll go to the city scale, and then we'll go to an evaluation framework to choose indicators. So the next speaker is EBVs towards a fit for purpose urban biodiversity indicators.
Good evening, good afternoon. So I'm coming from Australia, so my mind is. Anyway, thank you for joining this session. And I'm sure that from this room, everyone has used indicator in one way or another. But I just want to say this, fit for purpose indicators are not chosen, they're actually tested. So today I will take you through the guideline that I will propose to test different urban biodiversity indicators that can serve different urban contexts. Sorry. Okay, that's all fine. So I'm sure that you know about this. Cities are actually hotspot for threatened species. This is one national park in Nairobi. You see the rhinos. When you go in Australia, there are almost 40 threatened species that are urban restricted, that making cities to be the last chance for saving those species. So why this is more complex to adopt biodiversity indicators? Look at this picture. There are more than 10,000 urban centers. Something which is really interesting, they are called urban ecosystem, but they are very different, socio-ecological complex. We have cities from high income, from low-income countries such as slum cities. We have mega cities, we have small cities, that's beautiful. We have also cities from arid regions. So we can really imagine if indicators been developed by one scientist from one city, it can be transferred to other cities in a simple way. So okay, good. So why this urban biodiversity which can really be so urgent to be developed? When you look at this recent publication from urban ecology, you have seen that from the context of target 12, which is actually the urban related indicators, is actually the most vulnerable in terms of not having indicator that can be useful for this target. Even if you go to look at the headline complementary indicators, still this target is really vulnerable in terms of missing some key indicator that can be relied on. So yes, we can really say, okay, we can keep going as we do, but this is the consequence if we don't really do indicator testing. So we usually say we need robust indicators, which are policy relevant, data sensitive, user friendly. But when it comes way we validate it, it's more like expert judged. But we have to remind ourselves that even in some contexts, there are the experts even disagree. And whenever we go to further stage, we tend to test indicator for just one context, or even for one city, one site, or within one system type. So when you look at the first target, when you look at how some indicators have been mismatching from national reports to global reports, you see that there is really huge gap that we need to fix. So this is happening for most common indicators. So we can imagine about those emerging and unknown indicators that we want to adopt for the future. So this research is that then any test multiple indicator that can bring this cross-policy scale reporting. So from global to local, or from local to global. So the objective of this study was to develop a guideline for real-world testing for biodiversity indicators against their screening criteria, then evaluate what the guideline will be about each tested indicator. So the way we developed the guideline was not actually coming from nowhere. We rely on this OECD guideline, which is very recently adopted. And we tried to it was actually developed for project intervention purpose, but we tried to translate this to one indicator. So we picked the key element from this guideline, which is actually that the list you see there, defining goal of evaluation, remove ambiguous definition, and also try to understand the dimension of the criteria you want to test. So I just want to go straight to the results. That's where we also see more about the, the guideline and how it has been applied. So I don't want possibly to spend time on this. This was mainly to look at the different steps the guideline will have to take. So how three key steps. One was to selecting indicators for load testing site. Second one was professionalizing indicator load testing. Then the third one is just to look at evaluation process. So just to give you the sense from the step one, so the guideline is more about defining what you really want to test, particularly from the indicator dimension. So that's why we use the questioning system. For instance, there we say which cities best represent the diverse context of urban centers. To get there, we managed to get 98 cities that are actually crossing continent from high, low-income countries across a different region, and also across from city size, bigger cities to small cities. So this is somewhere that you can really say, if I have indicator tested across those sites, I can at least have confidence that it really can serve the purpose. Then the second step, which was operationalizing indicator for load testing, the aim was just to assess indicator performance against the screening criteria. Remember previously I talked about that we said some criteria, policy relevance, something like that. So right here I want to show you two indicators that are tested. When we look at this from urban context, they look different. But if you pick the species richness or species diversity, those doesn't really tell you nothing about those patches. So we usually use those traditional metrics. So very recently, the Callahan and they have tried to develop more metrics, which is relying on the bird species threat. So Callahan developed that threat for each bird species across from citizen science data. But what he was intending is just to make sure that each bird is assigned its adaptability score to the urban environment. When you use that score, that is actually the value in the red color. So each species goes to the same value. When you get those values, you get now the site urban score. That site urban score is actually telling you now more information about those habitat quality. So in the subsequent slide, I'll be talking about site urban score, which is actually the value aggregated from a sampled community of the bird that present in each little area. So because I have more than 5 criteria that I have assessed, in this presentation, I'll be only focusing on 3 criteria that I want to show you this expression how the guideline works. So still in the questioning system, is the species adaptability score invariant when calculated from continent specific data set? So this is more on conceptual of the methodology conceptually, because the developer proposed that the scope can be based on the continental bird record. But when we look at this data from the GEO, we find that some birds they are present across different continents. So then that is going to be challenging for the the developer how this is going to work for a species which is present across different continents. But we tested the stability of adaptability score across continents using 990 continent species. So when you look at this map, you find that using the Wilcoxon test, it has been reported that species, if you use data from continent, but when you look at the global record of that species, the score is changing, is actually variant to the continent. Then, therefore, we find the the urban species adaptability score up to 7,945 species to really to make this forward. So this defined threat basis is publicly available and it can be used for other studies. So that is something that we might really miss if we really move forward without testing these indicators for adoption. Then I look at the data availability. Again, coming back to the guideline, you need to really define the criteria you want to test or the objective of the test. So in this context, I look at how do the metro urban score. Remember, that is actually the adaptability score from each bird community present in that city. How is species richness response to variation in bird record? So when you look at metrobial species richness and scale manipulation, it's clear that it is really sensitive to data volume, which means that if you have enough reports, you're more likely to have more species richness in that city. But when you use this metrosite score, it was really not responding to data volume, which gave this metrics to be able to use for comparison across different cities, regardless of the data volume. The third one, possibly coming back here, this is another way to understand the guideline. So you, from here, I have looked on one dimension of the, the criteria, but you can test it a way of data volume, data availability, not just only the data volume. So there is more dimension you can really test. So then for the practical for the policy relevant, you need to understand why this is going to be for policy relevant. So we usually use to say, okay, we have green space, greening policy. So what we try to test in this context, we look at the proportion of the green space in each metropolitan area. This is actually the XY, which is like metro green space proportion. It is 0.6, which means that 6% of that metropolitan area is green space. But what we want to look at this context was really to say, okay, if we want to use those species richness or site-based metrics, which one can really tell us about greening policy? So when we look at this, we find that from those 98 cities that we selected, the site-related metrics was showing that the larger proportion you have, the poor habitat quality, because the higher value you have here means that the poor habitat quality, the rest you have the habitat quality. That was different from the species richness. Species richness was invariant, was not responding to this context, which means that species richness was not responding to this greening policy. So you can really take species richness to evaluate greening policy. But this one was at least showing this. But we get more questions. Maybe this is not real. We try to subset the city, looking at from high income city where we believe that they have management of those green space. Again, the site-based metrics was also showing that the larger proportion doesn't really mean better habitat quality. Again, the species richness was not really taking any relationship on that in terms of greening policy. Then we go deeper, looking at tropical region. That is why we have city from low income, but that's the particular region where you have high urban diversity. When you look at this, again, the site score based pick the sensitivity of that context, but at this time, species richness again show now the larger proportion of green space you have, the more likely you have high richness. So that was contrast now from the tropical region. So that gives more sense on understanding our metrics before we adopt to the policy context. So the key takeaway message, despite those socio-ecological conflicts in urban ecosystem, guided systematic testing with indicators can lead to suitable indicators. It's not a problem that we have complex socio-ecological context. So the second was, if you apply this systematic testing, the monitoring supplies such as what we have seen previously will not be coming. We can prevent them. Third, the trade-based indicators show really great performance. We can really be pushing forward in more testing context. So then we have to adopt this guideline for developing more fit for purpose, particularly for the target 12 for this context. So thank you, and possibly if I have 1 minute, question can be welcome.
No problem. It's okay for you guys, you can stay 10 minutes more.
There's redundancies between my intros and talks. Hey, everybody. I will make this into like a 70 talk so that we can. So my name is Catherine. I'm a postdoc at the university. I'll be showing something that I did in the first year of my postdoc with Laura Pollock, where we were able to select indicators to track subnational progress for Quebec. So this is going to be a talk about how to choose indicators, not how to calculate them, because as you've seen, there are plenty of indicators in the world. Very briefly, we know this from the talk we've just seen, but indicators are a useful way to turn data into action and to measure targets that hopefully improve the state of biodiversity. And priorities for biodiversity are set at the global level, also at the national level, and then that informs subnational strategies. Hopefully we're measuring those things at all those levels in a way that allows for progress from on-the-ground actions to trickle up into progress reports and to be visible in our 2030 to 2040 target evaluations on a global scale. But to do this, it might not always be the same metrics that are useful at the subnational scale and the global scale, as we've been talking about this whole session. Quebec, you guys have seen this map before. And Vincent helpfully introduced the fact that Quebec has its own 2030 target. It's called the 2030 Future Plan that is linked to the Global Biodiversity Framework. So this is going to be a talk about how we assembled about 65 people to recommend 15 indicators for the same plan in 6 months. And I'll be talking about the criteria and the filtering strategies that were the most useful for this exercise, and also some of the challenges and recommendations for doing this in other places too. And the materials that I'm going to be showing for running the workshops that we ran are all available in the paper that this is presenting. So if you want to reuse this stuff, it is available. Looks like this. So step one, the first thing is to create committees. So this just means bringing people together and assigning various roles. So there was a core committee, which was in charge of managing the project. That included me. There was a scientific committee and a consultancy committee. The scientific committee was to do scientific evaluation, basically. The consultancy committee was to do practical evaluation of indicators. So this was a lot of like conservation practitioners, local government associations that are doing projects on the ground. And the core committee was government, but also academics that had a broad knowledge about indicators and modeling to help kind of bring everyone's insights together into something hopefully useful. Step two. Step two is to make an inventory of all the indicators that are out there that could be relevant for this exercise. So those first three categories are the Global Biodiversity Framework ones. And then we also had Canada level ones and Quebec level ones for biodiversity. We also asked the communities if they knew of any other metrics that could be useful to follow, so they were about maintaining them added to the list. Step three, relevance. This is a big one. It seems simple on the surface, but it's really just making sure that we have indicators that are directly linked to the target. We could have opened a giant discussion for many days about this, but really we had a warning. So we did is we printed out the targets on paper, we gave people pens, we gave them a list of indicators, we put them in round tables, and we told them to draw lines between keywords of the targets and indicators that track the keywords. Very, very useful as a way to cut the fat right away. So about 120 indicators right off the bat were put to the side. There's about 45 that had some relevant. Step four. This is the scientific quality step. So for this step, it was the same scientific group here. We developed criteria together to evaluate the quality of indicators in a general way. You might already be familiar with the SMART criteria. I'll go too much detail, but we added a C criteria here, which is communicable, because indicators' main focus is really to communicate. Measurable, so it's a reliable and transparent metric. Achievable, is something that's actually feasible operational-wise. It's irrelevant to the target, but also quickly enough to make decisions, but also the time is relevant for the process. And then also, we translated these criteria into a set of yes or no questions, which we can assign a grade to. So this is a way, not necessarily to grade it, but it's more of a relative grading system. Yeah, so these 150 might still be good for other. Hi, it's practical. This isn't really too much. We want to get around roundtables and also what use cases they make or what projects they're working on that contribute. We ask them to mention how did you do this? This will also just have afterward volunteering their time very happy. We made these kind of report cards where we ask them to give us a use case. To give us information about what minimum metrics they would need to have. We also asked for a wish list of information that they would like to have to involve the reproducible development. We got comments, drawings, and there's a lot of open work. This kind of something very important. No indicators of criteria are currently. So just because you're about to it has a practical use. So we brought back some indicators that were rejected. Step 6 is step back. Look at the target keywords. And there were some times that we indicators back into practice. So we ended up with a short list of 50 indicators, which are approved or developed very fast. We have 8 indicators that we want to develop, which would be very relevant for practical data for more technology for and they want to use distribution. And there was a big list of non-recommended indicators that are not necessarily. We have a deal with indicators for subnational stuff. They're not designed to do that. They're not totally fine, but we need to work on some of these gaps like local short-term skills. There were common conflicts across indicators. One of the biggest ones is that it's very, very hard to evaluate whether an indicator is actually a good metric or a data. Testing, power analysis, documentation for some indicators. So this is a really hard one to use. Relevance to targets was surprising. A big filter, I would say. I think we assumed that metrics that sound good are going to be relevant to track change, but you always have to keep in mind what you're doing. So targets into the indicator is very important. Yeah. Make sure what we can put into action. And that's what I think I was like. Takeaways that don't really come into the like filtering in a formal way, but that are kind of in this throughout, is that trust is kind of the most important criteria. You can't really just draw a list of indicators and assume that those are. So bringing people into this process is almost more important than just like the best indicators out there. And we're only choosing the best we have now. I wish this was a list of like the top 15 indicators that we should be using. It is not. It's the best we currently have and that we are able to use. We should reevaluate this. Thank you.
I have a question that maybe applies to the last two talks because we both address how to generate indicators, but we take a top-down approach where not experts what are the best indicators. And I appreciate the fact that we made it mental. Usually talking about indicators and how to work. We spend a lot of time talking about indicators and not doing it. And the result is more bottom line. You know, let's see what we are. You know, we test it here, what's the pattern, and then we are and that's the effect. So, you know, what's the drawbacks and the conditions people might spend a lot of time talking about the data, and then at the end of the year, you get money.
Well, there's a lot of indicators out there. I don't think we spend enough time talking about what they're actually measuring. Like we have a ton of indicators on larger scales, but always seeing so many indicators, but we also have this like we're not. I don't know, timeline of what's happening in biodiversity. I think everybody can look. Yeah, I think the top-down approach is helpful when there's already some indicators out there in a way, because you need some kind of like ground to start off on to like, okay, we know this, which is the most useful to develop going forward. Rebecca's kind of starting out in a way that to make this, so it's a nice timing, but there's some that already have a bunch.
Possibly that is another chance for me to get question. But I think what we tried to do was to make sure that we test those indicators from, like she tried to do things for, one particular location. But what we are trying to do is just to take that metrics, which is seem to be one context, then we try to see if it can pass to another side. And that the guidance that we're trying to propose can really speed up that process. So within 1 year or 2 years, we can have many indicators now with a suitable to particular purpose. If it just for reporting cross, comparing cities, cross policy scaling, that can be really easy.
I'm curious, both your opinion again. If there's the distortion of scale makes the difference between the two approaches. For example, you were using the biodiversity richness versus this other urban signal. But is it possible that since you are at a very small scale versus Catherine's process was conducted at a state or provincial level, that would make the difference between the relevance of ground-tested approach of indicators that were designed for larger scale to city scale versus top-down selection?
So I guess from our context is more from top-down approach, top-up approach, bottom-up approach, where we really make sure that if you want to go up scaling, like you want to look at the country level, you take the country city exact, then you have to get that national rate. And you can say, this is how cities are performing, which might be different just when you have national research and you want to really look at each city how it's performing. You run a more issue with data context, data scale, data, something like that. I guess you can add more information about that. That is the difference from looking at the local scale, then you go up, versus from top down.
Yeah. Sticking around in a very warm room.